My birthday in a week. Yeah.
Lipids! Lipids are the subject of section 5.3, which if you would look on your agenda online, it is available online. It's posted on my website, of course. 5.3, basically that means, remember you're supposed to read 5.2 for Monday. Today, our topic is lipids. What are lipids? Does anybody know?
They are.
Zach says they are.
Fats.
Fats. Fats. Oils. Oh, oils. And waxes. And steroids. Wonderful things like testosterone and estrogen, not to mention andro and other illegal steroids, are also lipids, technically. And we'll learn about what those are a little bit later. But basically today we're going to learn what a fat molecule is. Well, I'll tell you what. Let me show you something. Here, I've got a little animation because we'll talk a little bit about the properties of lipids and a little bit about the chemistry of lipids, and it'll be great. So did everybody write that down so that I can erase it and get it out?
Yes.
Fat. So you can still actually, it's okay. It's still up there if you really can see it. I'll get rid of it in a second. But I have a drop of oil on top of water. And oil, people say oil is repelled by water. That's not really true. Oil is slightly attracted to water. Water is slightly attracted to oil. But water is more attracted to itself than it is to oil. And oil is more attracted to itself than it is to water. And so oil will spread out on top of water. If it didn't like water a little bit, it wouldn't spread out on top of it because it's spreading out much like the water did on top of the glass. It wants to be near it. But the water really wants to be with itself more. And that's why oil tends to end up on top. Well, it's more dense. But it doesn't tend to be able to go in. I can try to use my cursor here to drag it under the oil, or under the water, and the water, as it says here, water molecules are more attracted to each other than the oil. So water excludes the oil more than repelling it. People sort of tend to think that they will go apart from each other, and they really don't. It's not like that. Anyway, so there's that. But what exactly is it made of? Now, I'm going to show you this. Actually, I'll show you this in a second. Let's turn this off. That was just to give you some idea of one of the properties of lipids. Another thing I would ask is, what do lipids do? What do fats do in the body specifically? Fats, so in the body, fats, or well, lipids really, but they insulate. Okay, that's true. Meaning they literally insulate. Any animal that you're going to find that actually survives way up in the Arctic has a large mass of insulating body fat. Whales, polar bears, seals. That's why the sharks love those seals so much, because they've got a whole lot of fat. Fat has, okay, what's another purpose of fat?
To store food.
Well, to store energy.
Yeah.
Right, store energy. Just so that you know, and fat is long-term energy storage. We learned yesterday that carbs can store energy. You can store energy in starches. Long chains of sugar molecules put together into starches. But that's still sort of semi-temporary storage. You put stuff in the form of starch when you want to use it relatively soon. we keep some starch around in the same way that people keep some cash around in case of an emergency or whatever. But I mean, that's what you're supposed to have. I don't have this because I don't have that much money. I have some. I actually don't even have any money in my pocket. But let's assume that I did. That would be like the money in your pocket is like simple sugar. You might just spend it really quickly. But if you have an envelope in an emergency traveling kit, which, you know, the Weather Channel says, keep an emergency traveling kit with, you know, $500, believe it or not, and, you know, flashlight, batteries, food for a few days, and clothes in case you have to bug out during a storm or something. That would be more like complex carbs, you know. It's something that you're not going to use right away, but you want to have it. Fats are long-term storage. Fats are like putting money in the bank to earn interest and use later. Fats have a lot more energy. Fats can store a lot more energy. Carbs are about 4 calories per gram, whereas fats are 9 calories per gram. And so they store more than twice as much energy. So fats are long-term energy storage that we keep in our bodies. Okay. So fats are good. Okay. And there's one more thing that fat actually does, aside from the things that steroids do, which we'll learn about. Fats also they don't just insulate, meaning hold heat. They also just cushion organs. They protect organs from shock. So I'm pretty safe, I guess. Okay, so I want to move on to the chemistry of fats. Why don't fats mix in water? Why?
Polar.
They're non-polar, that's right. Let's see what that means. What functional groups, this was mentioned, can you tell me what polar molecules tend to have in common? There's a functional group, there's a certain element you see a lot of in things that are polar. We learned 4 functional groups that can be attached. Carboxyl, hydroxyl, so COOH, that's carboxyl, hydroxyl is OH.
Carbonyl and amino.
Carbonyl is CO and amino is N. H2 attached to something. So these oxygens tend to make things be pretty polar. Okay? So when you have things that have a lot of hydroxyl groups or carboxyl groups, they tend to be polar. So this is the thing. And when they don't, they're not. For example, lipids, fats, have these long chains of carbons that don't have any oxygen on them. All they have is carbon and hydrogen. And you probably should write this at least once. Actually, you're going to have to do it twice. I'm so sorry.
2 times?
That's what I said. I was not lying to you. Don't count on that in the future.
Oh my God.
I lie to you guys routinely, actually, but
Do we have to do that many C's?
no, you don't have to do that many. You just do realize that this whole thing is non-polar. Well, and this is called a fatty acid. Okay, and they call it an acid because it does have a carboxyl group at the end, which So, and anyway, you don't bother counting these. Just make a bunch. These can be anywhere from 6 to 26 carbons long, and so the point is just to realize it's a long stretch of carbon. Like again, you have to recognize these. Could you tell the difference between this and a glucose molecule? Well, I hope so. Remember, glucose molecule, whatever. You saw it yesterday. I'm not going to torture you with that again. But the point is, this is very different. Long, non-polar chain. there is a polar region at the end, and we'll see that this is used to connect to something in a little bit. But I need to teach you one other thing about these fatty acids. Here's the thing. This is one kind of fatty acid, and then there's another. I want to, they're still all nonpolar, and it's still a long chain of carbons. But do you remember, okay, how many bonds does carbon have to make?
4.
4, that is correct.
4.
Now, the other thing is that sometimes carbon shares one electron with another carbon, and that's fine, and that means that they would have hydrogen on each side here. That's normal. Well, the other way is normal too, but another thing that can happen is it can share, it can share 2 electrons at the same time. Just don't overthink it, it just can, okay? And if that was the case, if this carbon was sharing 2 electrons with the carbon next to it, then it would, it's called a double bond. You're okay? You don't need the Heimlich maneuver. Okay. Good, because that would mean you were eating in class. Okay. Yeah, it's okay, but if you ever do need the Heimlich maneuver, please, raise your hand. And, you won't get in trouble for eating in class. Okay, folks, here's the thing. Well, look, wait, easy now. Stay with me. So these 2 carbons have a double bond, and that just means that instead of this carbon getting its other electrons from 2 other hydrogens, it's only going to be attached to 1, and it'll get 2 of those electrons from another carbon. It's not that big a deal. It just happens. And then maybe this one is still going to be single bonded to the next one, and that's fine. That's life. That's what the people say.
Why do they write that?
You do. And let me separate these just so that you can see they're different. So they're different. And here's a term that we use. When every carbon in a long fatty acid is attached with all single bonds, then it's called saturated. When every carbon is not connected by all single bonds, when there's double bonds, guess what it's called? Sorry? Trans. That's an interesting guess. You get taking that from like health stuff. I'm afraid not. This one's called saturated. This one? Unsaturated. Unsaturated. Think about it. Full. Saturated means full. Unsaturated means not full. What's it not full of? Hydrogens, or single bonds, really. All right. Any fat that has at least one double bond in it is called unsaturated. So write that down. We're really almost there, folks. We're almost there. This is there's one other small thing to learn. We'll save lipids for another day, or we'll save steroids for another day. We'll do steroids another day.
Sounds good. It's not as funny a joke as it is.
I know you guys wonder how I get so huge.
I mean, baseball's the next. Oh yeah. Sure, but it's not as funny a joke as it is in health.
What? Not a funny joke.
I need him for baseball. In health,
it's drug humor. I'm making drug humor in class. That's bad. Steroid humor is still drug humor. That's bad.
In health, it's actually drug humor.
Yeah.
Do drugs tomorrow.
Oh. Okay, folks. So, are we there yet? Did we draw ourselves a double bonded fatty acid there?
Yeah.
Okay. So, the other thing is. Okay, COOH. It turns out that a fat molecule is actually 3 fatty acids connected by a molecule called glycerol, which you're going to see in a second. But the point is that you get, guess what? Another dehydration synthesis reaction that's going to connect this and one other. There'll be another fatty acid chain here. And this is actually what a fat is. So it's 3 fatty acids connected to basically a connector. It's just like a thing that, what's that? Glycerol, Glycerol. And you'll see it when you do your reading. When you read 5.3, you'll see it. So that's your fatty acid there. And I'll give you another minute to write this, and then I'm going to show you an animation because I want you to know, and this will be the very last thing, and then we're going to go to the computer lab and do something moderately okay.
Are we taking this stuff?
Moderately?
Yeah, you can take your stuff. I see just a tiny bit of writing, so I'm going to, you people that are still writing, you can either do it from memory, or this diagram that I'm about to show you still has fatty acids in it and glycerol. So I'm going to erase this, and I'm very sorry, but we're running short on time, and people are running short on attention. So you have been great with this stuff, by the way. You're going to learn one more macromolecule on Monday from Mr. Redmond, which you'll be learning about proteins, and he will teach you how to test for lipids. And he will teach you about proteins, and he'll teach you how to test for proteins, and he's going to do a really fun exercise on how proteins get their shape. You're going to love it. Okay, everybody. So this here is what you just saw. 3 fatty acids. They made theirs even longer. Notice how 2 of them are saturated. Now they wrote CH2, but just be aware, that's the same thing that you guys saw. So it was C, H on each side. They just write CH2 instead of C with 2 H's because they were trying to save space. And notice how one of these is unsaturated because it has a double bond here. It's kind of small. You might or might not be able to see that. Hold on. That's a little better. Double bond makes it unsaturated. Single bonds make it saturated. And why does this matter? What is the difference between saturated and unsaturated? Again, you're going to read about this. But the thing is, saturated fats, because they're all straight lines, they like line up with each other and they clump together. And they, first of all, can anybody think of something that has saturated fat in it? You hear about this, health news and whatever.
Chips.
What's that?
Cheeseburger.
Cheeseburger. Okay, yeah, beef. Animal fats tend to be saturated. Animal fats, including milk, butter, cheese, things like that. And so this delicious-looking muffin here with butter on it, these are saturated fats. The molecules pack really tightly together. Saturated fats are easy to tell. They are solid at room temperature. Butter, beef fat, pork fat, even chicken fat. Hard cheeses, meaning like cheddar cheese as opposed to like, soft cheeses like goat cheese, cottage cheese, things like that. Hard cheeses, butter, beef fat, they pack up like this, and so they clump up together, solid at room temperature. Also, where else do they clump up? Inside your body. They clump up. They tend to clump up a lot more easily. That's why saturated fat is not really good for you, because it can tend to clog up arteries. Yes?
Is that why when you drink milk it turns into a solid when it gets in your stomach?
I do not know the answer to that.
I
didn't even know that it did, to be honest with you.
Really?
But I want to move on because I want to show you unsaturated fats. This is the last thing, folks, so bear with me. You guys have been great. Unsaturated fats, because they have all these double bonds, they're bent. They don't clump together. They don't fit together as neatly. They don't stack up on top of each other. Unsaturated fats tend to be things like vegetable oils. Vegetable oil and fish oils, also, same thing. Unsaturated. They don't clump up. At room temperature, they're liquid. So therefore, in your body, they also tend to be what we call good fats. When you guys don't have to do this, but I'm an old man. I go get my blood tested at my doctor once a year, and he gives me a report. I get my fat levels, saturated fat, and then good fats. My good fats are supposed to be high. My saturated fats are supposed to be low, which of course they are. But again, olive oil, almond oil, canola oil, avocados, cashews, peanut oil. So nuts also have a lot of good fats. Fish has a lot of good fats. Okay? All right. Thank you very much, folks. We'll talk about steroids at another time. Y'all have been great. You've definitely earned your weekend.
Did you know that